Also, as a reminder, for more Microsoft webcasts, you can visit Microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Programming SQL Server 2008. And now, without any further delay, I'm going to turn the floor over to today's presenter, Vaughn Washington.
Thank you. This is Vaughn Washington. I am a developer in SQL Server, particularly focusing on native database access. And today we'll spend some time talking about the new programming features in SQL Server 2008, previously referred to as Katmai. So let's get started. So as far as the topics that we'll be covering today, first we'll start with a survey of sorts of the set of data access technologies that you can use to access the functionality in SQL Server 2008. This will, to some extent, be review for those of you who are familiar with SQL Server 2005 and previous versions. There are some changes around specifically the range of technologies and how these things sort of work, what the go-forward picture is for them. After discussing that, we'll focus on some specific examples of programming improvements for database application developers. We'll include things that show up in the most recent public release of SQL Server 2008, which is CTP4. Later in the presentation, I'll have a link where if you haven't already gotten your hands on it, you can start to actually play with these bits and the pieces of functionality that we'll be talking about today. So without further ado, let's jump in. Actually, before we jump in, we'll just cover sort of some of the prerequisites as far as technology familiarity that will help you to understand the features we're discussing and the technologies that are involved. So just to kind of briefly go over here, ADO.NET, part of the .NET framework, is the generic data access story for applications developed in the Microsoft .NET framework that have a need to access databases. So in particular, we'll be focusing on the SQL Server provider, sometimes referred to as SQL client in the .NET framework. Also, for those of you who are familiar with the native ways that SQL Server exposes to access the database, and in particular when I say native, I mean C, C++. We'll also be covering a lot of ODBC and OLADB functionality. So we'll go into more detail there once we actually get to the slide and discuss specifically what's changed here and what will change for SQL Server 2008. In addition, we'll cover some T-SQL concepts, some programming concepts for SQL Server, just touching on technologies like data types, stored procedures, functions, and specifically in SQL Server 2005, CLR integration was introduced, sometimes referred to as in-proc CLR access, providing the ability to write CLR assemblies that actually run as stored procedures inside of the SQL Server relational database process. So we'll touch on that some as well. So we'll start by looking at the data access technologies that you can use to take advantage of some of these new features. In SQL Server 2008, we've introduced quite a large number of new features. And again, we're just touching right now on CTP4, but you'll see more as future versions of SQL Server 2008 are released. To take advantage of these, in most cases, you will need to update your client driver or provider that you're using in your application. So the first I mention is the version of the .NET framework, version 3.5, which is currently in a public beta release. So these are bits you can download off of MSDN and start to play with. So in the most recent version, there are changes in the beta that allow you to take advantage of the new functionality in SQL Server, and we'll get in as we cover each feature what those changes are. For Windows native access, C, C++ access, we also made significant changes in ODBC and OLADB. One thing to touch on and clarify, so when I refer to SQL Server 2008 native client, some of you might not be familiar with that. In SQL Server 2005, we for the first time decoupled data access from the Windows, what was previously referred to as MDAC, the Microsoft Data Access Components. And we split off the SQL Server native client from what's now in Vista branded as the Windows Data Access Components. The message there is really that we never want the deployed application to be broken with any changes that come out in new versions of the product or the server. And those applications should continue to work. Again, as we touch on each feature, we'll just briefly talk about how it's exposed to down-level clients. And you'll also have noticed that I said in most cases you'll need to upgrade your client. In some cases where possible, we've exposed the new functionality in such a way that existing applications using, for example, the Windows Data Access Components can continue to get access to that data. But if an application is really taking a bet on one of these new features, chances are they'll want to rebuild, to test their app fully as they're making this application upgrade, and to try out the functionality with either ADO.NET or ODBC or OLADB. I've also mentioned, I covered Windows Data Access Components. I've mentioned that additionally the JDBC driver. The JDBC driver was new in SQL Server 2005. It will continue to be able to access SQL Server 2008, and on a separate schedule, they'll continue to look at upgrading that driver and taking advantage of the new functionality as well. So as far as which data access technology is right for you, there are 4 factors that you really want to take some time to think about. Probably the most important one is if you're doing an entirely new application, if you're writing it from the ground up, then the .NET framework is almost always going to be the right choice for you in terms of ease of application development and just the shortened time to write the application. It will usually be the right choice. There will be some cases when your scalability needs cause you to need to build on top of a native driver provider. Another consideration is if your application already exists and is coded on, say, Java or in C or C++, then the cost of rewriting that application is going to be significant. So in those cases, you may find a need to also choose, again, a technology other than the .NET framework. The one case that is worth calling out at the same time in the migration scenario is if you're migrating an application from a database other than SQL Server, you'll frequently also find that there's less cost adopting, say for example, the ODBC API, which we tend to find is the closest to competing database APIs. And again, I've mentioned that if your application is moving from a database, another case to consider is if your application actually supports multiple databases. In that case, you'll frequently find that a database abstraction layer like ODBC or ADO.NET makes the most sense. So factors to consider, and also I've mentioned platform restrictions and availability. The SQL Server native access client is available only on Windows. The JDBC driver that Microsoft ships works in any environment that supports Java, and ADO.NET can go anywhere that the .NET framework can go. So the one other high-level point that I'd call out as you think about which data access technology is right for you is where you see your application going. And by that I mean if you plan to continue to add features and innovate in this application and add these features in such a way that you're taking advantage of new functionality in the database, in the back end, then you'll more than likely want to adopt one of the data access technologies that's moving forward. And to clarify, I mentioned that Windows Data Access Components continue to work. So applications that are built on top of those components, the SQL OLADB and SQL ODBC provider and driver, will continue to work properly with SQL Server 2008. They will be able to connect. They will be able to use the features that those drivers and providers expose. They will not be able to take advantage of new features in an optimal way. So that's something to consider as you make that selection. So now, without further ado, we'll take a look here at the first in the set of features that we're going to examine for SQL Server 2008. Table value parameters. So let's talk background. So a problem that database applications commonly have is exposing, or let's phrase it differently, is designing in their application the concept where the app has what's conceptually a table of data. You can think of it as an order entry application. You can think of it as a web storefront. There's some grid of data on the client application on the website, and effectively the application wants to get this into the database in the most performant and optimal from a sort of developer cost perspective. So this is a problem that has existed for quite a while, and because of that, there are multiple ways that it is solved today. One of those ways is developers creating stored procedures that take a large number of parameters. And what they actually do with these inside of the logic in the stored procedure is they pivot these parameters into a table effectively. So, a simple example would be, let's say they have a stored procedure that takes 1,000 parameters, and each conceptual row is 10 columns long. It allows them to batch the data in the application, the web app or the FAT application, into batches of 10 rows, right? Actually 100 rows in that case, 100 rows of 10 columns. And in their stored procedure, they actually are doing the mapping to check if each row is present and to do an insert into a table or whatever business logic they need to do in the application. Another way of solving it is to use bulk insert into a temporary table on the server side. So the application could have already today used one of the bulk insert or BCP APIs. They could have used bcp.exe to simply pipe all that data into a table on the server side as fast as possible, and then use that temporary table in their business logic and their application the same as they would any other table. And it's not ideal from a programming standpoint because the bulk insert procedure is in many ways not in line with a lot of the other code that they'd be writing in their application, but it does get the data in pretty quickly. And then the third is leveraging parameter arrays in client application. SQL client, specifically ADO.NET, ODBC, and OLADB all expose ways of specifying parameter arrays in the client application. What that means is binding an array for each parameter that you're invoking on the server side. So you're in your application saying that I've got this, again, table-shaped data that I'm going to send over. Now, the application, actually the driver I should say, when it's actually invoking the procedures on the server side, is in most cases invoking a procedure that takes actually a scalar set of parameters. So your procedure on the server side is still dealing with these, again, conceptual rows of data one at a time, even though your application is more cleanly describing and representing the data in its natural state. So while the application code is a little cleaner there, you don't get the performance benefit you would if you were batching this data from end to end. So enter table value parameters, which is a way to describe data in your application in a natural way that has the same performance characteristics as BCP, meaning you're shipping all this data to the server in one fell swoop, you could say. So there are two application programming models that you can use when you're using table value parameters. One is very similar to the parameter array model, where you've got all of the application in your in-memory buffers in your application. So all your data is sitting in arrays and buffers, and you bind it much again the same way as a parameter array. And when you execute, the driver provider pulls it out and streams it over to the server. The other mechanism, which is particularly valuable when you've got large volumes of data, is to bind your data as a stream. And when I say stream, I mean stream in a generic sense, as it's done a little differently for each data access technology. But conceptually what's happening is you're binding the data and letting the driver provider call back into the application, either for single rows or batches of rows, depending on exactly how you've chosen to implement it. The performance of this model is better than parameter arrays in medium data sizes, as I'm calling out, and approaches bulk insert for large data sizes. So of course the performance characteristics will vary based on your exact implementation, based on the data types that you've got. But at a high level, you'll see a better performance than parameter arrays. And the big advantage is that working with data as a table value parameter means, in addition to being able to do this on the client, you also get to take advantage of this on the server side. So on the server side, you're actually able to specify that your input parameter is a table, which lets you do batching and set-based operations also in the stored procedure. So to give you a better idea of what I've been describing here verbally, let's actually try out a demo and see what you think of table value parameters. So switching here to some sample code. So starting here with the T-SQL procedures, and I'm just going to have a drink of water here while you take a peek at these procedures. So what we've got as the first procedure, the first two, and actually for now, if you want to just focus on these two at the top, we've got a T-SQL store procedure that is representing, actually two of them, that are representing an order and items. So the way to logically think of this is an order using the web storefront scenario is an order that a customer would make, and each order has one or more items in it. So you go to Amazon and you get a couple DVDs, you get some books. Each of those actual items is an item, and the order as a whole is an order. So you can see we're in this procedure just getting the current date, and we're inserting into our TVP order table, which again has a row for each order, and inserting an identity, a generated identity column value for the order. Actually, we're returning the identity, and then we have a separate procedure for inserting each item. So we will we'll call this procedure once for each item. So let's jump into the code. So this is an ODBC application that we're looking at. You could do the exact same thing with OLADB or SQL Client. OLADB, there's a bit more code. For those of you who are familiar with OLADB, it takes a little longer in most cases to do the same thing, while at the same time giving you a little bit more granularity as far as control of accomplishing it. So let's jump to the main routine here, and we'll just get started. I'll go ahead and start the application. Now what I also have open, and I will show you that here as we start running. So this place where we've broken is the beginning of a very simple example scenario. Now this is pre-TVP, you can imagine. This is an application that's doing the simplest thing you could imagine, simply invoking, see I'm highlighting the TVP order insert, invoking through ODBC, SQL exec direct, a stored procedure that inserts one row for the order, and then later it will invoke the stored procedure that that inserts one row for the item. And it will do that in a loop, and it will do it once for each item. So in this case, you'll see as I mouse over here, there are 4 items. So what that means is that we're inserting an order that has 4 item rows. Now I'm going to switch to my server, which is running SQL Server Profiler, which is a very useful tool. I'm going to clear the screen here from previous runs. Very useful tool to see exactly what's going on the server side. So this is useful for application developers. If you're not already familiar with it, I highly recommend it. It gives you a good insight into what's happening in the background. So SQL Server Profiler is currently running. I'm going to go back to my application. You can see we broke in right here. So let's do some running. So first, the application. Again, this is the very simple scenario. In these first lines of code was binding parameters for the order. So we called bind parameter 3 times. We're going to insert the order. All right, so if I switch back to SQL Server Profiler, you see we inserted the order. Particularly, let's make this a little easier for you to see, particularly right there. Now this, just to be clear, this T-SQL code you're seeing at the bottom isn't necessarily the exact code that the driver is sending. SQL Server Profiler does its best to make the snippet you see here the same logically as what the driver and application are doing, but this isn't actually T-SQL code that's being generated from the client side and sent to the server. This is the same logical T-SQL code. But the important details here are you see that we did invoke the TVP order insert method and that we passed in some data. We passed in some data to do that, and there was exactly one call here. This one row, RPC completed, in the top pane shows that we invoked it one time. So jumping down, let's see. We'll jump to the prepare statement. One important detail here for ODBC developers, and this also applies for other APIs, is that we're preparing the statement because we plan to invoke it multiple times. So you will see a performance benefit there. Let's actually run to this point. So we went through this loop, which invoked the TVP item insert multiple times. And what we should see if we switch back to Profiler is yes, in fact, we did insert 4 items. So there are our 4 items that we inserted. That corresponds to 4 round trips to the server, once for each of these SQL execute calls. So if I just come down here, the application's also generating output. Actually, let's wait 1 second. Go, and you can see the application generated 4 rows of data in the server using that model. We will run through the parameter array model also. In this case, the order insert is the exact same as before. So we will quickly just run through that. Now, this is actually a slightly more interesting piece here. This is the parameter array code. So this is where you see us binding the parameter and then actually setting a parameter array. It's basically a statement attribute that says what the parameter set size is, that says how large the array is. What this allows us to do is actually, when we execute the statement, to insert all 4 rows in one call. Now this is 1 round trip to the server. Let's go ahead and execute it here actually for you. This is 1 round trip to the server. The disadvantage is that on the server side, it's actually being invoked multiple times. So you see the 4 rows being inserted, and I clarified earlier that what you see in SQL Profiler isn't necessarily exactly what's happening in the application. You still see the 4 rows. That doesn't mean that we're doing a round trip to the server for each of those. What it means is that the stored procedure, the same stored procedure as before, is being invoked 4 times on the server side. So that's a clarification there. But you see we successfully inserted that data. And if I look at the output, there are your 4 rows. So now we're going to do it with TVP, which is the new feature. So take a look at the SQL bind parameter call, where what we're binding is actually a table. You'll see SQL SS table there to specify that that's the parameter type. You'll see in the documentation, if you play with CTP4 of SQL Server 2008, more details on exactly all of these parameters and what their meaning is. I won't dive in too much right now, but the key is we're binding a parameter that's a table, and then after that, we are actually going to bind each of the constituent columns of the TVP. So here, we've introduced a new ODBC statement option, param focus. So by setting this to the TVP, it allows us to then actually bind each column. So you can see here we're binding column 1 of the TVP, which is the product code, and then column 2 of the TVP, which is the quantity, and then we're changing the param focus. Now, before we execute it, actually, let me jump back and show you the stored procedure. So we created a type. We created a type which actually is a table. We named it TVP param, and it contains 2 columns, a product code, which is an integer, and a quantity, which is an integer. So remember, these columns are describing the actual row data, the columns of the row data for the order items. So here in our now combined procedure, we're taking the customer code, which is the same customer code that we took above in TVP order insert, and we're taking the actual TVP param, which is the row data. So switching back to the application again, see, we've set the param focus back to 0, and let's clear Profiler so you see exactly what's happening. So I'm going to switch back to Profiler. These are the previous invocations. And let's run this TVP order insert method. And now you see one line in SQL Profiler. You see quite a bit here. And again, I'll just point out one more time that it doesn't actually mean that we're generating insert statements. This is the logical representation of what actually happened. What actually happened was that we generated the table parameter in an efficient format and sent it exactly once to the server and executed this query. So the application provided this data, all of this data. We made exactly one invocation on the server side, executed exactly one procedure, and that one procedure, the contents, I'm going to switch back here, were what you saw here, which inside the procedure actually inserted all of the data. So it inserted the one row into the TVP orders table, and it inserted all of the items into the TVP item table. And here's the interesting part from a performance perspective. So you'll see an insert with a sub-select. So what it did was it batched all of that. It did one set-based operation to insert all that data. Now what gets really interesting is when you start using TVPs to do with where clauses and all sorts of other business logic for filtering this data. And that's where the real power of TVPs comes in. This is something that you wouldn't be able to do using the bulk insert model. So from a programmability standpoint, this is a big win. And while you could do it using parameter arrays, you'd be operating, this business logic would be operating one row at a time as opposed to using set-based operations. So that's really the strength of TVPs. So let me just run here so you can see what happens. We insert, well actually you caught me here. There's ignore the bottom data, but the important detail here is that we're inserting these 4 parameters with the TVP data also. And actually this bottom data is really just some diagnostic information about the actual columns of the TVP. Yeah. So let us switch back to the presentation. All right. So again, please do ask questions. We'll get back to this all here. So switching to date and time types, which is really interesting. This is something that people have wanted for a long time. So it's a pretty exciting piece of functionality in SQL Server 2008. Let me real briefly just cover what we had in SQL Server 2005. We had 2 types around date and time. We had a small date time type and a date time type. The small date time type had an accuracy of about a minute, and it was exactly a minute. and date time was 1/300th of a second, so about 3.33 milliseconds. You can see the ranges as well. This hadn't changed in quite a while, and this was consistent, with what was documented in the books online and the other sources. So problems that developers frequently had with these data types was, well, so you look at the scenarios that applications need date and time. Frequently, they'll just need a date or just need a time. And because the storage size is significantly different, if you just want those components, you actually end up paying a higher cost than you would have to if we exposed a way for you to just use the piece that you wanted. You also have to pay a price in your application, because what it means is now your back-end data type doesn't actually match what logically you're using in your application. So you need to have some mapping there, and maybe even some error handling in cases where somehow someone managed to sneak data into your database tables that you weren't expecting. So you got to do some filtering and management of that discrepancy. We also would see that the limited ranges and lack of time zone awareness would limit the ability of applications to use these types. Applications that wanted to get around this would have to either have additional columns to start to use year biases and various other tricks to get around the range problem, or just be forced to use something entirely different like strings to allow them to store the data in this wider range. And we also saw that there were migration problems because other databases and even the standards, the ANSI standards, had better support than these two types supported. So in SQL Server 2008, we've introduced 4 new types that should really address all these scenarios. We'll get to in just a second the ranges. What this slide focuses on is how these types are represented in client stacks. So we've called out in ADO.NET that actually let me just talk for a second here about these 2 types, these 4 types. So date is just a date, as you'd expect, time being just a time, and date time 2 is sort of an evolution of what was the date time type. It allows you to fully express, let's actually just jump to the ranges here to give you some background, allows you to fully express variable user fractional second precision. So what I mean by that is much like the syntax for variable length strings types, you can specify fractional second precision, aka the number of digits after the decimal point that the column or parameter supports in your T-SQL when you define the column or parameter. And the storage representation of that matches that precision. So what that means is that if you're actually not using any fractional seconds, meaning your application only needs whole seconds and you specify 0, you're not paying as much cost in storage as you would if you were using 7 fractional seconds or getting precision at the 100 nanosecond level. So this table shows you the difference between the types. The other big difference is this different range. You can see for all the new types, the range starts at 111 and goes to effectively the highest day in year 9999. Very exciting actually is the date time offset type, which introduces support for time zone awareness. So the type, in addition to storing an instant in time, also stores the time zone that it occurred in, ranging from -14 to +14. So jumping back to the client representation, so datetime 2 naturally fits using the same client models that the date time type did. The reason that works out is because the date time type already had fractional second precision, and the client representations were kind of ahead of their time in the sense that they already included a large enough scale or fractional second precision that they could support this 100 nanosecond precision. So we didn't have to make any changes there. For date, it's a very similar story. where existing types in client API technologies already were there to fully support it. The cases where we had to were for time for ODBC and OLEDB because the native types actually didn't support a time-only type that also had fractional second precision. They had one, but it didn't have fractional seconds. So there we had to introduce new types. And for date-time offset across the board, new types were introduced. Date-time offset you'll see in the ADO.NET column is actually a new type in the .NET Framework version 3.5. So that's actually a new type in ADO.NET and the .NET Framework that applications could take advantage of. So this is how you'll get at these types, and they're all first-class citizens in the sense that the same way you're binding data types and getting conversions today, that will continue to work, and these types should be targeted at being possible replacements. At some point, if your application can benefit from it, these should be fully able for you to take advantage of as replacing your existing usages of small date time and date time. So let's just again glance through the new type slide. You can see everything we've talked about here. These types should in every way be superior to the existing types. Moving on to another piece of new functionality in SQL Server 2008, unlimited length CLR user-defined types. So, for those of you who are scratching your head saying, oh, I don't quite know what you mean, SQL Server 2005 introduced the ability to generate .NET Framework CLR assemblies, CLR standing for Common Language Runtime assemblies. So what this meant was that if there was business logic that you couldn't or didn't want to implement as a T-SQL stored procedure, and there would be various reasons why you might choose not to do this. One being that from a computational cost standpoint, T-SQL isn't the best language. You don't really get the best performance implementing computationally expensive logic in T-SQL versus .NET Framework assemblies. You get much better performance. So in those situations, that's just one example of when a user might choose to implement that. You would use a CLR user-defined type in SQL Server 2005. Now, the limitation in that release was that the byte serialization was limited at 8,000 bytes. So what that meant was in your scenarios, if you had an instance of data that needed to be larger than 8,000 bytes, you were effectively blocked from being able to take advantage of the functionality. You could try to work around it, but in the end, really serializing the data became the bottleneck, and you just couldn't use it. So in SQL Server 2008, we've removed that limitation. And you'll see that now it's effectively unlimited length. In practice, right now, that limit is 2 gigabytes. That might change along with other max types in future versions. And by other max types, I mean varchar max or var binary max or nvarchar max. These types replaced the legacy large object types like in-text, text, and image in SQL Server 2005. So in SQL Server 2008, CLR UDTs become like these other types in the sense that they no longer have a limit on their serialized length. This also opens the door to interesting scenarios around user-defined serialization. So in order to use one of these types, you actually need to write a CLR method and specify it as your serialization method, your byte serialization method. And what that means is that when the server or one of the drivers or providers sends this data, sends an instance of a UDT from between server and client, it will invoke this method to serialize it and to deserialize it. So you own the format of your UDT when it's being transferred. The reason this is interesting is because it means that in addition to these things working flawlessly in the .NET Framework, these CLR assemblies, you now can take advantage of them in other languages and platforms, because since the developer knows what the serialization format is, they can write libraries or simply interpret the bytes in the way that they know they're being serialized. And You can do this for arbitrarily large sizes of data, again with the 2 GB limit that I mentioned. Now, you might be thinking, some of you, well, 2 GB is actually not that big nowadays, and that's true, which segues into the next improvement in SQL Server 2008, which is the file stream large storage object improvement. What this is actually a new attribute that you can specify on var binary max columns. So var binary max columns, I mentioned, were the replacement for image columns in SQL Server 2005. What most people do with these is store opaque binary blobs like actual images or files or any other binary data. The file stream attribute lets you actually, in T-SQL, when you define the table, say that I want this column to actually not be stored in line with all of the other data in my database, but to be stored as a file in the file system. So this removes the 2 GB limitation that we were just talking about and lets you have files as large as the Windows operating system will support. In addition to that, the file stream improvement comes with a few new SQL Server built-in functions for working with these files that are actually in the file system, but again, accessed transactionally in the T-SQL code that you're writing and in your application, just like var binary data would be if you weren't using the file stream storage attribute. So the 2 new SQL built-ins I mentioned are pathname and get file stream transaction context. You'll see in just a moment why these are important. There's also a new client interface in the SQL Server native client header file, OpenSQL file stream, which is also quite useful, and we'll see actually in the demo here as I walk through what that code looks like, how that's used. An important detail to emphasize is the performance benefit that you see with using Windows, basically WinAPI file streaming versus T-SQL streaming. So today, reading large object data from the server, whether it's SQL client, ODBC, or OLADB, you'll see decent performance reading large files. And by large, I mean 1 GB. The files in that large range where really that transferring of the file is a significant portion of the performance of your overall application. With file streaming using the Win32 APIs, or in this case the OpenSQL file stream API, you'll see a significant performance benefit. So that's very useful. That should be very useful for applications that do that. And one example would be a document management system. So let's jump in. Let's jump into to a demo. And in this case, rather than walk you through all the code, instead I'll walk you through what it would look like if you want to start to take advantage of this. Now, one detail, what you're looking at on the screen right now is the SQL Server Native Client header file that ships with SQL Server Native Client. So applications that are building on top of the ODBC or OLADB driver provider and taking advantage of new functionality in SQL Server 2008 would want to become familiar with this header file, just in the sense of that it describes how, well, let me phrase it differently, it provides the support that's necessary to use the SQL Server specific functionality that's not already in the OLADB or ODBC generic headers and specifications. So for our purposes, I will jump down to the bottom of the header file and look just at file stream. So this is effectively what's new for client applications who want to, on the client side, build on top of file stream. And I'm emphasizing that difference there because applications, all applications where it's valuable, could immediately start with a schema change and change their storage attribute on their large object column to start being stored as a file. And it's important to point out that there are no application changes needed to just enable that scenario. That scenario simply works with a schema change, and applications should start to, on the server side, see a benefit there. The client change I'm talking about now is an application that wants to start streaming using Win32 APIs instead of using the T-SQL streaming mechanism. So you'll see I've highlighted this OpenSQL file stream method, and it has a number of parameters: the file stream path, the desired access, which looking back here, you see there's an enum which includes multiple options for your access, some open options on the file handle, a transaction context, a transaction length, and an allocation size. So I mentioned in the deck that the transaction context and the path would come up again. So I've switched now to a SQL file, and I'm just going to kind of walk through what it would look like. So in order to start using FileStream, you're specifying a new attribute. So this is just a simple table. I'm imagining that I'm storing specifications, specs, in the database. I've added the FileStream attribute here to the create table clause. One second as I have a sip of water here. So what this attribute does, in combination with some earlier T-SQL that you'll see in the documentation around modifying the file group that this table was created in, actually specifies that this column should be stored in the file system. Now later in my application, when I'm writing the code, what I would do is I would start, well, the transaction, most likely in your application you'd want to do this. Based on your needs, you might not need the transaction, but I would select a spec from the table, and you'll see what I'm actually doing here is I'm getting the path name of the spec. So this path name will come back as a column in the select clause, a column basically in the result. And that column you would then pull the value, pass the path name, and I'm going to flip back here on you, pass the path name as this parameter to OpenSQL file stream. The transaction context you can get by calling this function within the context of the transaction and passing the context and its length as these parameters. So this is actually data that you're getting from SQL Server as you're querying your actual file stream column value on the server side. And one clarification, I mentioned the transaction you may not need. The API actually does require that you open it under the context of a transaction. So if you were going to use OpenSQL file stream, you would actually be doing it under a file stream. So you can see actually the first benefit, file stream, just changing your storage, requires no application change. And the second benefit, doing streaming, is fairly simple in the sense that there's one new API you're calling and you're replacing your calls for, again, replace this with the actual API you're using based on your data access technology, but you're changing a bind call or the ADO.NET data reader to use OpenSQL FileStream instead. So that is FileStream. That is SQL Profiler, which I've mentioned is a valuable tool. All right, getting back here to the deck. So just to briefly go over what we covered. So we talked about what data access technologies work well. Well, let me phrase that slightly differently. What data access technologies you can use to get all the power out of SQL Server 2008. And we also mentioned the other options out there for you. Table value parameters. We dove into it, showed you why you need table value parameters and how to use it, what benefit it provides. The enhanced date and time types. We talked briefly about why we needed new types, and then showed you the new types and talked about some of the ways that you would gain improvements in your application by using them. And then we talked about some of the limitations that we removed from SQL Server 2008 using the new CLR, unlimited length CLR types and the file stream storage attribute. To provide you just a little bit more information for you to go out and collect some more on your own. There is a SQL Server Connect site which you can sign up for to actually get the newest CTP for SQL Server 2008, and also to start to submit questions, or if you find bugs or any problems, you can actually create requests there to address those issues. MSDN also has a section dedicated to SQL Server data access, and that is msdn.com/data. And there are a set of forums also for SQL Server. In particular, there's a SQL Server data access, and I believe the .NET specific forum is SQL Server.NET data access and storage. And those forums are incredibly useful if you're playing with these things and have questions and want to get out there and see if anyone else in the community has hit similar problems. So thank you for listening, and I will hand things back over to Tracy.
Excellent. Thanks, Vaughn. I do want to remind everybody that for more information, you can print a PDF of today's session. To do that now, you just want to go to the File menu in your upper navigation bar. Now's a good time to submit your questions into the Q&A panel. You just want to type them in and hit that Ask button. Also, I'm going to be posting a survey here in just a minute. If you would all please take a moment to fill that out before you log off. We really do appreciate your feedback. Now, for upcoming and previously recorded webcasts, you'll want to visit Microsoft.com/webcast. You can go here to access this webcast, which will be available for download in about 24 hours. And if you have any webcast content ideas, something out there you would like to see and haven't yet, we'd love to hear from you. Just take note of this link here. And here's the survey from our session today. Please follow the links provided to complete today's webcast evaluation. And Vaughn, it looks like you have some questions waiting there for you.
All right, thanks. So let's start taking a look at these questions. So the first question. So I've got a question about the example. I think this is it's the table valued parameter example. So is it normal to have a stored proc taking in 1,000 parameters, for example? Well, it's a good question. Is it normal? Well, I guess my first thought is it really just depends on the application. I would say yes, it is normal for some applications. Some applications have actually taken advantage of the fact that you can specify 2,100 parameters to work around limitations in parameter arrays and sending table structured data. So I know that there are many applications out there doing it today. In practice, I would say that it's not the best code to maintain, either on the server or the client side, having stored procedures take that many parameters. It really means that your programming story is a bit odd. Now, having said that, I'm not the expert when it comes to all application scenarios. So there might be scenarios out there that work well for particular applications. And one question for you, Tracy: should I provide an answer also in textual form, or is it sufficient just to verbally answer?
Go ahead and just read them out verbally.
Okay,
that's
thanks.
Perfect.
Thanks. So the next question. Tom asks, in SQL Profiler, you mentioned that it might not be the same code as in the client. Can you explain what has changed? Well, to clarify that, it is conceptually the same code. What's different in some cases is that SQL Profiler will actually generate T-SQL that represents what the driver actually did. And the only reason why that's happening is that if you think about what the driver's doing under the covers, sometimes it is generating a SQL string, much the same way you would if you were using SQL Server Management Studio or Query Analyzer to generate your T-SQL. But sometimes what the driver is doing is actually generating what we call an RPC, or a remote procedure call. It's also sometimes taking advantage of the wire format being used under the covers, the TDS wire format. And what that means is that these things might not be able to be represented, well, let me phrase it differently. They can be represented in T-SQL, but sometimes it's a little misleading if you believe that exactly the string that shows up in SQL Profiler is exactly what the driver's sending. Now, logically and conceptually, and even from a data standpoint, what you see in SQL Profiler does represent the actual effect of what the driver's doing. So that's really the distinction I was trying to make there. Thanks, Tom. So Fred has a question. are there new functions to combine a date and time for comparison to an old date and time? There are actually quite a few new functions around date and time. Now, let me first answer one question that I'm not sure if it was the question you were asking, which is date time 2, if you remember, is the new replacement for date time. That can easily be compared to a date time or a small date time. So there are straightforward ways to compare those two. Now, regarding whether there are actually functions to concatenate a date type and a time type to compare it with a date time, I'm not sure off the top of my head if those exist. I know you could accomplish it using a combination of T-SQL, because there are methods like date part and time part that let you break things apart. So I believe you could construct fairly easily, even if there's not one function that does it, fairly easily a date time 2 or a date time out of a date and time. If you're doing it through a client API, it's even easier, because in the client we've got structures that are the recommended way to use these things. So if you've got a date in your client and a time in your client you want them to go into, say, a date time 2 or be compared to a date time, you can simply stick them in that struct and simply say to the client driver that it is a date time and use that for comparison. So Blue Jean has a question. Am I understanding this correctly? Datetime 2 is similar to datetime in SQL Server 2008, just that datetime 2 will allow 111, but datetime doesn't. So there are two main differences between datetime and datetime 2. The first is the actual date range. So datetime, and actually I'm going to assume it's okay for me to switch back here to the range slide.
Actually, we'll want to go ahead and keep us on to that survey if we can.
Okay.
It collects all that data.
I'm going to go right back to the survey.
Sorry about that.
Oh, no problem. So the datetime 2, the main difference is the year range. The second difference is the fractional second precision. So in Blue Jean's question, he or she asked whether 11100, basically 0 for hours, minutes, and seconds, and milliseconds was the only difference. There are two differences there. One is the year range, the date range, I should say, and one is the number of digits after the decimal point that you're able to work with. So hopefully that answers your question. Another question from Al Stein. Does 2008 natively understand date minus date equals interval? For example, next. It's a good question. I think the question is a question about T-SQL. The same operation could be attempted in the client application. I think the question again is about doing this operation in T-SQL. So we have, I'm looking at the question. The question says date minus date, but it asks for an interval of 1 hour. So really this question, I think, is about date and time, not just about date, because there are methods, date diff and date add. They're T-SQL functions, built-in functions for doing these sorts of operations. So those operations would let you easily do this on a date time type. So short answer, yes. Date add and date diff should let you accomplish this sort of comparison straightforwardly. Would have to dig into the exact API to figure out if it would give it back to you in hours, or if you'd get a new date, which was simply the difference of the two. Gunther B has a question. Is FileStream already shipped in CTP4? Well, Gunther, that's a good question. I think the answer is yes. I believe it is. You're making me nervous by asking the question, but I believe that it has shipped in CTP4. Yeah, that's the short answer. Take a look at connect.microsoft.com/SQL, and that will have the definitive answer. I'm pretty sure that that functionality did go out in CTP4, which is also, I believe, referred to as the July CTP. I think that's the correct name. Take a peek. It's either June or July. I think it's the July CTP. So that's what I was referring to as CTP4. Adria has a question. see, are there any upgrades to SSRS in 2K8? Will there be an overview? I believe that is SQL Server Reporting Services. That's what I'm going to guess your acronym is. And yes, there are large numbers of upgrades. I personally can't speak to them. I'll take an action item just to try to find out if there is a way for me to communicate it back. I'll try to get that back to you. I would guess that yes, there will be one. It might just take a little bit of talking with people to make that happen. Let's see. What about, so this is a question from RK. What about a distributed application that is used from all corners of the globe where clients do updates using their local date time, which screws with the filtering by date time column, as 8 p.m. in Japan is much earlier than 1 a.m. in U.S. Also, each client wants the date time in their local time zone, which could be a day earlier or later, depending on where they are. Please address. So actually, this is a great question because I believe the answer is yes. The date time offset solution completely addresses this. So the behavior in client application stacks is slightly different depending on the stack. But what you'll see using datetime offset we'll use as an example ODBC and OLADB in the SQL Server Native Access client, is that the client app by default, actually let's stick to datetime offset. I was going to, for a second, bring in the question of conversions between datetime and datetime offset. That's unnecessarily complicated. So the date time will always be in UTC or Zulu, and the time zone offset will tell you what time zone offset the operation happened in. So applications can choose how to display that information. Applications can choose whether they want the times to show up in local time or in UTC, but the data's there such that nothing would be screwed up as far as filtering. The data's all there, both on the server and the client, and there are functions to pull out the pieces you want and to convert from local time to UTC. So you should be safe designing an application like that. Another question from GCART01. Are there any canned pivot query functionality, or if we still need those lengthy stored procs to do a cross tab or pivot? I'm not exactly sure what the question is asking. I think it's asking, in the case where you're using large numbers of parameters, is there some assistance as far as their built-in support for doing that sort of operation? And the short answer is I'm not sure. I'm really not. I don't think there are any built-in functions for helping an application accomplish that pivoting of parameters. Now there is a concept of pivoting in T-SQL, but it's not quite the exact same. And I'd refer people to take a peek at books online. I'm also not particularly experienced with using pivoting when it comes to the other uses in T-SQL, but I believe there's a reference in books online on the topic that should be helpful. Response from Blue Jean saying thank you, so I'm glad I answered Blue Jean's question. And a clarification. He means that if you have field names pivoted with columns and rows. Okay, I think I understand now. So the question was if your field names are actually in your data, is there a way to pivot, to pull those things out? And I believe, I've done this in Excel. Honestly, I've never tried it in data that's in SQL Server tables. So I'm just going to have to say I don't know the answer. I could take a guess, but I've never actually tried that using T-SQL to do it. So there may be, there may not be. I'd refer you back to the documentation. And sorry I couldn't be more help on that particular issue. So seeing no other questions, I'm going to hand it back to you, Tracy.
Great, thanks, Vaughn. Well, with that, I do want to extend a very special thank you to Yvonne for your presentation today and for answering all the great questions we had come through the queue. Well, ladies and gentlemen, this is going to conclude today's session. I want to thank you again for joining us. You may now disconnect from the audio portion of today's presentation.